Okay, in this video, we're going to take a look at a few word problems that involve variation. That just means that these word problems involve two or more things that vary with respect to each other. Okay, so take a moment to pause the video and read those words that are on the screen there. There's just a few ways to translate some of the words that you'll see in these word problems to math equations that you're going to want to use to solve the problems. So go ahead and take a quick pause here on the video and read those different translations that are listed there. Okay, now that you've read those translations, you should have picked up on some keywords. The keywords that we're going to be looking for in these problems are the words varies as, varies jointly as, varies inversely or is inversely proportional as, varies directly as, and varies as the nth power of. Okay, so those are the keywords we want to look for, and those are the words that are going to tell us what equation we're going to want to use. Okay, so now let's take a look at an example. The variable p varies inversely with n. So now if you notice, you should have already picked up on the keywords varies inversely with. Okay, and the variables that we're going to use are p and n. So from the translations that you read above, hopefully you can see that the equation we want to use here is p equals k times 1 over n, right? Because that's the equation that we use when we see the words varies inversely. Okay, so now there's our equation. So where it says find an equation to represent this relationship, okay, it gives us some information here. Find an equation to represent this relationship if n equals 1/2 when p equals 8. So it gives us this information so we can go ahead and substitute into our equation for n and p, and that's going to allow us to solve for our constant k. So let's go ahead and do that. We're going to substitute p for 8 and 1/2 for n, and we'll go ahead and simplify this. 8 equals k times 1 divided by 1/2. That's the same thing as 1 times the reciprocal of 1/2, which is just 2 over 1. So we get 8 equals k times 2. And now if we divide both sides by 2, we'll get 4 equals k. And now that we have k, we can go ahead and plug that back into our original there to get p equals 4 times 1 over n. And now this is the equation that represents our relationship between p and n. Okay, so we found the equation that represents the relationship between p and n, and now we want to find p when n equals 12. Okay, so the thing we're doing here is we're asking ourselves, what is p if I let n equal 12? So I'm going to go ahead and substitute in 12 for n. So I get p equals 4 times 1 over 12. And we'll go ahead and simplify and find p. So this gives me p is equal to 4 over 12, which is equal to 1 over 3 when I reduce. So when n equals 12, p is equal to 1/3. And that's it. There we have it. We've found p when n equals 12, so we've answered the question in the word problem. Okay, let's take a look at a second example. The weight of a body varies inversely as the square of its distance from the center of the earth. If the radius of the earth is 4,000 miles, how much would a 200-pound man weigh 1,000 miles above the surface of the earth? Okay, so in the first sentence, the weight of a body varies inversely as, there's our keywords, varies inversely as the square of its distance from the center of the earth. Weight varies inversely as the square of its distance from the center of the earth. Okay, so we're going to go ahead and choose some variables here to represent weight and distance, because those are the two measurable quantities that we're talking about here. So the weight, I'm going to go ahead and use W, and the distance, I'll go ahead and use D, and varies inversely. That tells us that we want to use the equation W equals K times 1 over. Now be careful here. You might think to just write D here, but notice it says the square of the distance. So the square of the distance, that's D squared. Okay, so W equals K times 1 over D squared. And now let's take a look at the next sentence. If the radius of the earth is 4,000 miles, how much would a 200-pound man weigh 1,000 miles above the surface of the earth? So this information here, the radius of the earth is 4,000 miles. And the man, when he's on the earth, is 200 pounds. So if I draw myself a little picture here, here's the earth, here's the center of the earth. The radius is the distance from the center to the outer edge of the earth. We're given that that's 4,000 miles. And if my man is standing on the earth, then he weighs 200 pounds. So this is telling me that W is equal to 200 when D is equal to 4,000, right? Because the weight varies inversely as the square of its distance from the center of the earth. So 4,000 is the distance of the man from the center of the earth. And when he's at that distance, he weighs 200 pounds. So this information right here is going to allow me to solve for K. So we said W is 200 when D is 4,000. So let's go ahead and plug that information into our equation. We get 200 equals K times 1 over 4,000 squared. And let's go ahead and solve for K. We get 200 equals K times 1 over 16 million. 4,000 squared is 16 million. And then if I multiply both sides by 16 million, I end up with 3,200,000,000 equals K. Okay, so now that I have K, I can go ahead and take that and plug it back in up here. And that'll give me the equation W equals 3,200,000,000 times 1 over D squared. And now let's go back and see what this word problem is asking us to find. We want to know how much would the man weigh 1,000 miles above the surface of the earth. So if the man is no longer on the surface of the earth, so let me change my picture here. So now the man is up here. Okay, and that's 1,000 miles above the surface of the earth. And the question is, how much does he weigh up there? So that means we want to find W up here. We don't know what W is up here, but we can see that his distance from the center of the earth is 4,000 plus 1,000. So that's 5,000. Okay, so what this is saying is, what is W? So I'm going to draw a question mark here. When the distance of the man from the center of the earth is 5,000. So I'm going to go ahead and plug in 5,000 for D and solve for W. I'll do it up here. W equals 3,200,000,000 times 1 over, distance is now 5,000 from the center of the earth, so 5,000 squared. So now if I simplify this, this is 3,200,000,000 divided by 5,000 squared, which is 25 million. And if you divide this out, you end up getting 128. So what have we found? We found that the man weighs 128 pounds when he is 1,000 miles above the Earth's surface.